Hi everyone. So this is going to be a series of videos about the coalescent. So I'll just give a brief informal introduction to the coalescent right now. So coalescent theory is a way of describing our expectations of the shapes of trees of alleles. So let's back up and see what that means. That means if we have some population and we sample some individuals out of that population, the question would be, what's the relationship between those individuals? Or let's say we sample these 5. So there's some questions there. One would be, how long does it take? How long ago did these two things diverge from each other? And then overall, what's the shape of the tree? So for instance, we'll learn that the deepest branches, as I've drawn it here, the deepest branches in the tree are much longer than the short ones. So these are the sorts of things that we're going to work out. So this is somewhat unfamiliar because often what we do is we talk about relatedness of species. And with the relatedness of species, we don't have as much of a specific theory of what those should look like, right? So for instance, if we just have some species on a normal, in a normal continent that's not changing, I don't know, maybe the relatedness between them and their times of divergence will look like something, and I'm not sure, because it depends on specific events that happened. So to give you an example, if on the other hand we're talking about a tree of species that colonized an island, so you see this like with New Zealand, which is a relatively new island, what you see is basically there are moments, some millions of years ago, after the island was created, that you have a species land. And what you find is that it radiates very rapidly, so that your species trees tend to look like this. Because all of these events involve speciation events where you get occupation of a new niche by where this one species splits and occupies new niches. So what that means is when we're a thing we're more accustomed to thinking about relatedness between species, these tree shapes can kind of look like whatever. We don't have, it depends on the specific history. So for instance, if you have a mass, another thing that can happen is if you look at your tree, if you look at your trees in terms of times, what you'll see is these times where you get lots of these radiations, right? So where we have a radiation of species here, and then in another lineage we might also see a radiation of species at right around that same time. Well, that kind of thing can happen if, for instance, there was a mass extinction here. So a lot of species got wiped out, leaving more niches unoccupied, and then leading to a radiation of different lineages. Okay, so to contrast that in the coalescent, so here, when we're talking about the relatedness between species, we're often talking about very long times that can include these drastic global events that affect the shape of the tree. By contrast to the coalescent, we're just talking about the history of the individuals within the species. So instead of talking about when I diverged from a chimp, we're talking about when I diverged from you, or at least when each of my genes diverged from each of your corresponding alleles. So over these shorter times, there's just fewer variables, and we can actually sort of write down what we mathematically expect for tree shapes. And so that's the main goal of the coalescent, is to describe mathematically the shapes of trees of alleles. So that's what we're going to get into.